Hello, tensor friends. In my never-ending battle with general relativity, uh, I must say that I've learned more about tensors than I learned about relativity, which I guess is okay, but I don't know what I'm going to do with it. Anyway, that's not the point. I've been using these transform, if that's the right word here, over and over, where you can have a contravariant vector component and change it to a covariant vector component, multiplying it by the tensor components. And inversely, you can do the same thing to obtain a contravariant. And I just used this when I'm thinking about it, and then I thought, why is that? Why does this work? What's going on here? Well, after reinventing the wheel and pages of math, I finally realized how actually easy it is. A little bit embarrassing, but it was fun. So you know that a vector, which is a tensor rank one, yes, uh, is a linear combination of its can be expressed as a linear combination of its components and its basis vectors. Now, whenever you see an E in this, it's a basis vector. I didn't put the little ding over it because it's hard to do in this cheap software I use. Anyway, so we can do this. Now, let's dot both sides of this with a contravariant basis, the vector. So we got the v bar dot e, the super I. All right. So now we can put our parenthesis here and express this as e, the covariant dotted with e contravariant, and you know what this is. This is a basis vector dotted with its reciprocal, which is the Kronecker delta. And since I equals I, then this is just equal to 1. So now we have an expression. The vector dotted with this basis vector is equal to the contravariant component of the vector. Okay? Now, we can also express this vector as a covariant component with a contravariant basis vector. It's just as legal to do this as this. They're equal. Okay? So now we can take this expression and put it back in right here, and we get this. And you know already what this is. Now let's put the parenthesis around that, and you know that this is the inverse metric, the tensor, the contravariant metric, the tensor. So we have the contravariant metric, the tensor, times the covariant component will give you the contravariant component. So that's how easy it was to do that identity after, I don't know, I spent like an hour on it, I guess. Anyway, I thought that was fun. I'll see you later.